All right, Unit 3, Lesson 3, this is on angles of elevation and depression. So with these problems here, for the most part, I'm just going to prompt you to how to do them. We should have the skills to do them, we just need to set it up and kind of talk through the difficult parts of each problem. So the first thing here, just to help you understand the idea of an angle of elevation and an angle of depression. So when you're standing and you look ahead of you, you have a natural line of sight, okay, which goes horizontally, right? So that's like your line of sight there I've just drawn in. If you look up to see something, then your line of sight changes like this. And this angle between your line of sight and the horizontal is called the angle of elevation. And then by the same token, when you look down, this in here is your angle of depression. Okay, so most of these problems relate to the fact that you're standing, you look up to see something, or you look down to see something. But it's always between the horizontal and your line of sight. Okay, so just be careful with that. It might seem obvious, but there's mistakes that people make. So let's have a look at a couple of the word problems that we have here. All right, so I'm just going to set this one up. A man is standing at a point on the ground 50 meters from the base of a building. If the angle of elevation to the top of the building is 50 degrees, find the height of the building. And it asks to draw a diagram to represent the situation. So your diagram should go first because that will help you to make sense of it. All right? So here's the ground. We'll say we put our building in here. Now, so the man is standing at a point on the ground 50 meters. So we'll say he's standing here. So it's 50 meters from there to the base of the building. All right? From there to there, these 2 points. That's a 50-meter distance. If the angle of elevation to the top of the building is 50 degrees, okay, so we're not talking about from his eyesight here. We're actually talking about from the ground. Okay? So the angle of elevation will be the horizontal that we're talking about here is the ground. So we look from the ground, from the point that he's standing to the top of the building, makes an angle of 50 degrees. And it asks us to find the height of the building. The height of the building is x here. So now you see we have a right triangle situation, and we just need to use our trigonometric functions. And you'll see here that because x is opposite the 50, and because the ground is adjacent to the 50, we're going to use the tan ratio. Tan of 50 equals x over 50, and that will help us to solve it for x. Okay? Let me see. Next one. So, our next situation. So, slight alteration of the last one, nothing too complicated. So, what we're saying here, from a point in the ground 30 meters from the base of a building. Okay, so again, we're talking about the ground, the base of a building again. So, we know that the angle of elevation to the top of the building is, let me do that again, 36 degrees. Now, there's a flag on top of the building. Okay, here's our flag. And the angle of elevation from the same point on the ground to the top of the flag is 39 degrees. All right? 39 degrees. And the question is here to find the height of the flag. Okay, so here's how I would go about this. Look at what I'm going to draw in green. All right? So what I've covered in green there is the right triangle with a 36-degree angle in it. Okay? We know that we're 30 meters from the base of the building. So if I use that green right triangle there, what I'm finding is the height of the building. Okay, so you can again use the tan ratio to do that. Now, if you watch what I highlight in yellow, look at the triangle I highlight in yellow. Right, if you use that one with the 39-degree angle, you're going to find the height up to the top of the flag. So now what you have is you have the height of the top of the building and the height of the top of the flag. If you subtract them, what's left over is the height of the flag. Okay? Next one. A pole is standing upright in the ground supported by two strong cables one on each side. Okay. So let's draw in our ground again, and here's the pole. The cables are attached so the angle of elevation to the top of the pole from the cable on the left is 52 degrees. 52. And 34 degrees from the cable on the right. Okay. Okay. So that's our situation. Find the total amount of cable necessary to support the pole. Now there is something missing from this question. We do need to point out as well that the pole is 20 meters high. Okay, so that's the height of the pole. So I'll actually write it in here, 20 meters. All right, so to solve this one, let's again look at what I've got in green here. All right, so we want to know the amount of cable that we need. So we want to know, let me see, this distance here, we want to know this distance here, and we want to add them up. So what I'm going to do is I'm going to find this x here. Well, you have 52 degrees, you have a 20 and you have an x, so it's opposite and hypotenuse, so you're going to do sine with those measurements. And then if you look at the triangle on the right, which I'm going to highlight in black, okay, in this one, you have a 34-degree angle, you have a 20-meter side opposite it, and we want to know the x. Well, we'll call it y here because it's going to be different. So you can use the sine ratio again to find y. So you found then at the end, you found the amount of wire necessary to go up this side here. And then you found how much to go down this side here. So how much cable is needed to support the whole pole? Well, it's x plus y. You add them together once you find them. All right. Okay, this case, a man is standing on top of a cliff, and here's our man, and here's the cliff. And out on the ocean somewhere, he sees a boat. Now, don't think of it as being a huge boat. Just think of like he sees a little boat out here somewhere. All right, and now, so if the boat is 800 meters away from the man, not the base of the cliff, find the height of the cliff. Okay, so the angle of depression is 62 degrees. So we're going to imagine that we're talking about, so here's his line of sight, and he looks down. So we're going to say that that distance there is our 62 degrees, right? So we just imagine that the boat is a point in the ocean. So here's the thing to be really careful of, right? A lot of the time when people are dealing with angles of depression, they'll say that the 62-degree angle is this one here. But that's not true. The 62-degree angle is from the angle of depression, or from the horizontal down to the line of sight. So the 62 is actually in there. Okay, which means that this angle here, which I marked as 62 before, is actually 28. And it means that this angle here is 62. Okay? So, we also know that the distance from the man down is 800 meters. And we want to find the height of the cliff, which I'm going to mark in green. I'm going to call it x. So, what you're dealing with now, I'm going to highlight it in, I'll do it all in green just to make it stand out, the triangle that you're dealing with. Is that there? There's your right angle, and you want to find the height of the cliff, which is this here that I'm just going over again. So you have a 62-degree angle, you have an 800-meter hypotenuse, and you have an x, which is the height of the cliff that you want to find. So you're looking opposite hypotenuse sine ratio. Next one. Two buildings are 100 meters apart. Okay. The angle of depression from the top of the taller one to the top of the smaller one is 15 degrees, and the angle of depression to the base of the smaller building is 40 degrees. Find the height of the smaller building. Okay, so let's see. We have two buildings. Let's draw in our ground first. So two buildings here. Tall one, small one, and the distance between them is 100 meters. The angle of depression from the top of the taller building to the top of the smaller building is 15 degrees. Okay, so we have to put in our horizontal line, and we draw that there, and this is 15 degrees. And the angle of depression to the base of the smaller building is 40 degrees. So it's from the same spot again, from the top of the taller one to the base of the smaller. That's going to be, I'm going to put that in red actually. That's 40 degrees. Okay, find the height of the smaller building. So if you look at this here, right, it's going to be very easy for us to find the height of the taller building. So what we're going to do, I'm going to highlight in green, look. If we find the height of the taller building using this right triangle and knowing that this angle in here is 50 degrees, make sure you understand why that's 50 degrees. Okay, we can find the height of the taller triangle, and then watch what I mark in yellow. If we look at this right triangle here, I'm going to call this here y. We can find y. We have a 15 degree angle. We have y. We have a 100 meter side as well. So by using that yellow triangle, when you find y, you're finding the difference in height between the big one and the small one. So if you find the height of the big one, find what y is and subtract it from the big one, you're left with the height of the small one. Okay? So in 6, a lady stands a certain distance from the base of a building. From this position, the angle of elevation to the top of the building is 22 degrees. She moves 20 meters closer and the angle of elevation becomes 36 degrees. Find the height of the building. Now sometimes, look, it can be good to draw these things separately. So I'm going to show you this strategy for drawing them separately here, right? So a lady stands a certain distance from the base of a building, and from here the angle of elevation to the top is 22 degrees. Okay, so we're going to say this is the first situation. There's the building, this is where the woman is standing, and the angle of elevation 22 degrees. Now this certain distance that we're talking about from here to here, we're going to call it x. And then the second situation, she moves 20 meters closer, so we have the building again. She moves 20 meters closer and the angle of elevation becomes 36 degrees. So if the original distance up here is x and this is 20 meters closer, then this distance here is x minus 20. Now the question is asking us to find the height of the building. So we're going to call the height of the building y. Now, to work from here, this is quite tricky. What we need to do, we're going to try to find two expressions for y. So let's have a look. So if you look at the first one, right, we have two variables. We have an x and a y, and we have a 22 degree angle. So the x is adjacent to the 22 and the y is opposite. So we could say then that, let me see, tan 22 equals x over y. Or sorry, it should be y over x actually, because it's opposite over adjacent. Y over x. Now if you look below, in the second one, you can see that tan 36 equals y over x minus 20. Now, let's just use our calculators for a second and see what we can get here. So tan of 22 is 0.4. So where I have tan of 22, I'm going to cross it out and replace it with 0.4. And then we're going to go down to tan of 36. Check that in our calculator. Tan 36 is equal to 0.73 if I round. Right, so let's just go down. Okay, so now we need to just bring a bit of algebra into this here. So if we look at the first expression at the top, okay, you have 0.4 equals y over x. So just to use our knowledge of algebra, that means that to clear the x from the bottom, multiply both sides by x, you're going to have 0.4x equals y. Okay, that comes from this expression here. And then on the other side, you're going to get 0.73 by x minus 20 equals y. Alright? So what's good here is you'll see that because both of those are equal to y, remember our transitive property, see? This is equal to y, this is equal to y. So because of the transitive property, they must be equal to each other. So let's bring that into play here. So we're going to put down that 0.4x equals, and I'm going to use the distributive property here, 0.73x minus 14.6. Okay, so let's do a bit of algebra. We're going to subtract 0.73x from each side to get all the x's on one side. So we're going to get minus 0.33x is equal to minus 14.6. So that then tells me that, using my calculator, x equals, let me check, 44.2. Alright, now that 44.2, that's not the height of the building which we were asked to find. That's actually the distance that the woman was standing from the building at the beginning. But look, if you know x, we know by going back up here, look, to find y is just 0.4 times x. So that means that y equals 0.4 times 44.2, which equals 0.4, 17.68. Okay? So 17.68 meters is the height of the building. There we go.